Hi everybody. In this video, we're going to look at a circle theorem involving the angle at the center and the angle at the circumference. But rather than just giving you this theorem, I'll guide you through how to discover it for yourself using GeoGebra. So if we go to GeoGebra, we click on Calculators and we want Geometry. So we need to draw a circle with a center. So we'll click on this icon and we'll draw a circle. Now we need 2 points that lie along the circumference, 2 more points. We'll have a point here and a point here. Now we want to draw some chords, so we'll click on segment, line segment, and we'll draw a chord between B to D, and another chord between B to C. Now we need 2 radii from C to A and D to A, so we click on C, we go to A, we click on D, and we go to A. So we have our diagram. We're going to investigate the relationship between the angle at the center at A and the angle at the circumference at B. So we need to measure these 2 angles. If we press more, we can see we have measure an angle, then we go from D to A to C, and from D to B to C. So we have these 2 angles. I'll just move them so you can see them more clearly. Now, there's a relationship between these 2 angles. To find this relationship, we can move point C and point D along the circumference of a circle, and trying to notice how the angle at the circumference changes with the angle at the center. Do you want to give this a go yourself? Try to look for a connection between the 2. Okay, so how did you get on with that? So we have 46 degrees here and 93 degrees here. We need to think about rounding because this could be 45.5, still rounded to 46, and this could be 92.5 rounded to 93. So we need to try a few points, and we can see that when this is 50, the angle at the center would be 100. When we've got 53, the angle at the center would be 106. So how do you think these are connected? So the angle at the center is double the angle at the circumference. And this is the first circle theorem. This leads on to the second theorem, where we have angles in a semicircle. If we have a straight line, 180 degrees at the center, then the angle at the circumference will be 90 degrees. So what this tells you is that the triangle in a semicircle is a right angle triangle. It's a semicircle because these 2 radii split up this circle into half. Okay? So wherever you move point C and point D, you can see the angle at the center is double the angle at the circumference. And as we progress through in this video, we'll be applying this circle theorem. So if we know the angle at the center is double the angle at the circumference, and we've got 112 degrees here, then we can work out angle X as 112 divided by 2. So angle X will be 56 degrees. You can use the same idea with angle Y, but we need to work out the angle at the circumference first. Well, we've got angles on a straight line, so this will be 40 degrees. And the angle at the center will be double this, so this will be 80 degrees. Okay? Do you want to try and work out angle H and angle G, and then try and find angle A? You need to combine the circle theorem with angles in a triangle and angles about a point. You can pause the video and come back when you're ready. Okay, so to work out a H, we can work out the angle at the center. And we know that these are 2 radii because they both come from the center to the circumference. So this will be an isosceles triangle, which means this will also be 36 degrees. And we can work out the angle at the center as 180 minus double 36, so minus 72. This will give us 108 degrees, which means the angle at the circumference will be half of that. That would be 54 degrees. And if these two lengths are also equal, then we can work out angle G using angles in a quadrilateral. But we need to work out this angle first, and we have angles about a point. So this will be 360 take away the 108, which is 252 degrees. And this angle will be the same as angle G. So we'll have the angles in a quadrilateral minus the 54 plus the 252. This will give us 2G. So we'll have 360 minus the 306 will give us 2G. So 2G will equal 54, which means angle G will be 27 degrees. With this question, these are our two radii, and these are both equal, and this is the angle at the centre. So we can work out this green angle as double the angle at the circumference. So this will be 256 degrees. Now we can use angles about a point to work out angle A. So we'll have 360 minus 256, which will give us 104 degrees. And that's angle A. Let's try two more questions. So this may not be obvious, but it's the same circle theorem. You've got the angle at the centre, this angle here, is double the angle at the circumference. Do you want to try and use this to work out angle N? And then for this triangle, it's the same idea. We've got the angle at the centre and the angle at the circumference. Do you want to give these two questions a go? So for this question, this angle will be double the 110. This is the angle at the centre. This will be 220 degrees, which means this angle, using angles about a point, will be 140 degrees. And now we can use angles on a straight line, so angle N will be the 40 degrees. Did you get that? For our green triangle, well, if the angle at the centre is 180, then this must be a right angled triangle, because the angle at the circumference will be 90. And if these two sides are equal, then angle T would be 45. Okay? Let's try two more. Do you want to try and work out angle F and V in this question, and angle G and H in this one? When you come back, you can check you're working with mine. Okay, so we've got the angle at the centre, 180. So this will be 90 degrees. This is the right angled triangle in the semicircle. We also know we've got angles on a straight line here. So this will be 180 minus the 98. This will be 82 degrees. These are both radii of the same circle. So these will be equal, as will this one. So we can work out V as 180 minus the 82 divided by 2. This is V as well. This will give us 49 degrees. So V is 49. And if V is 49, we can work out F, because V and F add together to make 90 degrees. So F will be 90 minus a 49. So F is 41 degrees. Did you get that? For our final question, we've got the angle at the centre, which is G, and the angle at the circumference is a 38 degrees. So G will be double the 38, G will be 76. And we know that these two lengths are equal because they're both radii. So 180 angles in a triangle minus the 76 will give us 104. So 2H, this one and this one, will equal the 104. So angle H is 52 degrees. Okay? In the next video, we're going to look at the circle theorem involving angles in the same segment. Well, I hope you found this useful. If you want more practice on this, you can download the worksheet and view the online lesson from my website, mrmathematics.com. I'll leave a link in the description below.